Here's, where's your space?
Okay. 4 or 5 notes. Yesterday we covered all 5 topics. Listen, we covered all 5 topics yesterday. We talked about finding the domain. It's just setting the denominator equal to 0 and solving to see what's off limits. And when you do that, you have also found the vertical asymptotes. The only disclaimer here, the only feature. Okay, this was happening at first. The only disclaimer that you need to be careful of is what if it's not an asymptote? What if it's a hole? The way to check is to have both the top and the bottom in factored form, and the hole would be the like factor that cancels. Give it a second. So what I was going to add right here was there is that small disclaimer that is watch out for holes, because a hole and a vertical asymptote are totally different. Then we did checking if there's a horizontal asymptote, and we learned that these two cannot coexist. There's either a horizontal or there's an oblique. There's never both. And then the last part for today was putting the graph on graph paper with the added extra points. And I gave you a preview of that yesterday by saying it's just as simple as picking a number, plugging it in, and plotting it. Let's go to the practice question.
Nice.
Good. Okay. This slide right here is a summary of everything we just did. So if you need some notes to highlight or reminders of how we do it, the summary page is right here. This slide is telling you how to graph it step by step. And today, in regular class, we're going to look at the test to see how is it going to ask you to graph it. I'm pretty sure it's going to ask you to answer, as in typing in, the vertical asymptote, the horizontal asymptote, the oblique asymptote, and then I think it's going to give you answer choices to select the graph. I don't think they have you actually go in and graph it yourself. We're going to answer that question in class today, so we'll know the answer to that. Go to this question right here. All right, so let's get back to the mindset from yesterday. Find the vertical asymptote. Find any horizontal asymptotes. If there's not a horizontal asymptote, find the slant. And then let's check it. We'll start simple. Notice this one does not need to be factored. It's in the simplest form already. So the vertical asymptote comes from looking at what?
Denominator.
Denominator. So x plus 2 equals 0. Solve it, and I get what?
-2.
X equals -2. Horizontal asymptote is your lead terms test. I don't have a lot of room here, so I'm just going to take the highlighter and highlight those lead terms, and then I'm going to look at the degrees. The degree 1 equals the degree 1. Do you remember then what the horizontal asymptote is? Yep. When they equal, you go back and you pull the leading coefficients. So this is a 1 over 1, so it's y equals 1. All right, the next part, x-intercepts, y-intercepts, extra points. This is kind of new. Please don't forget what x-intercept means and y-intercept means. X-intercept means the graph is crossing the x-axis, which means what has to be 0? The y is 0. What is the y in the original function? Remember? Oh. Alright, I was trying to erase. A minute. Good grief.
Does it not work?
I don't know. Alright, where is y in here? It's this, right? Okay, if I'm finding the x-intercept, then what goes right there for y? 0. Can you see, by the way? Okay, good. I can only do Alright, so if you need to take notes, set f of x equal to 0. Which means like you're taking the f of x, you're replacing it with 0, and you're solving. I love finding the x-intercepts because watch this. If I replace that with 0, I have this giant fraction on the right. Do you remember that math word starts with a P that I have here? What? Yes. Dang it. We'll start. Hang there. Okay, this is a classic proportion. There's an understood over 1 right there. So you're going to cross multiply to solve. But you're really only cross multiplying one side because the 1 that's right here does nothing over there, right? So I'm going to cross multiply this nonsense to the left, and what happens? Gone. Which means all I have is 0 equals x minus 3, so what's the x-intercept? You add the 3 over and you get 3. Now I'm going to repeat what I just said because that is so simple. Like if you're not watching what I'm pointing to, you're going to miss how I did that. To find the x-intercept, change y to 0, cross multiply, the denominator will disappear because it's multiplying by 0. You will then just focus on the numerator and you solve it and you get x is 3. Which means that at 3, 0, the graph is crossing. Now we're going to repeat with y-intercept. If we're looking for the y-intercept, what's 0? X is 0, which means go to the original, replace x with 0, and write down what you get.
Negative 3 halves.
Yes. So I'm going to set x equal to 0. I end up with y equals negative 3 over 2. Right? Now, translate that to a coordinate point. 0, let's do negative 1.5. Now, the last part is pick a few more points. Let's save that until we get it on the graph, because we don't want to pick more points than we need. We may not need very many. So now we're going to put it all together on the graph, so don't get lost in everything you just answered. We have a vertical asymptote at negative 2. That's too much. Wait a minute. Too much. Too much. Negative 2. Horizontal at 1. We're definitely touching 3, 0. We're definitely crossing at 0, negative 1.5. Where do you think the first curve is? Right there. Right here, directly in front of you, folks. It's right here. He's just going to shoot like that. That's the first curve. Now, if you want a few more points to really see where it is, you can. But for me, like, okay, it's going to be right here. You know it can't cross those asymptotes. Yes. We're going to answer that after. We're going to look at that. I think it's multiple choice. I don't want to tell you wrong because I haven't looked at it most recently. So I'm going to tell you. I'll answer the question in 30 minutes. Oh, it's gone, because it's gonna cross multiply to 0. Right? Like, imagine if I had this. I would have say x over 2. This would cross multiply. Right, what's the opposite of divide 2? Okay, in the hard one, what's the opposite of divide 2? Okay, so you can say multiply by 2. Multiply by 2, what do you get? So I'm just cross multiplying it over, but because it's multiplied by 0, it's gone. No, it'll never be a line. But yeah, but it won't be because we're looking at the x-intercept. Okay, remember what we talked about yesterday. We're not quite done with this picture. Remember what we talked about yesterday. We said that it's a function, so it has to pass the function test, which is that vertical line test. So please use common sense here. There is nothing up here because you've already plotted stuff right here. So direct your attention to where there is a blank spot, like entirely, which would be right here. Like that is entirely blank. How do I know where the graph is? You are picking numbers and plugging it in. Let's be smart about it. Don't plug -8 in. You want to pick numbers relatively close to that vertical asymptote because that's where it's curving and diverging, right? If I pick -8, all I know is it's either going to be here or here. But I don't know exactly where the curve is approaching. You know what I mean? I would plug in either -3 or -4. So, other points. We are going to pick. You can plug both in if you wanted to. You could do -3 and -4. It's up to you. Or you could just do one of them just to see where it is and then draw your curve. So you plug it in. So go to the function, right? And then plug -3 in. We got -3 plus 2. All right, now clean it up. So that's -6 over -1, which is 6. So go left 3, up 6. So clearly it's in that section, and I could sketch the curve, but just to practice plugging in again, I'll do -4. So repeat this with -4. Get -7 over -2. Negative divided by negative is positive. 7 over 2 is 3.5. Right? So I'm going to go left 4, up 3, and then halfway. So now I can see, okay, the curve's like right there. Please go to the next practice problem. What do you notice you're going to have to do first? You're going to have to factor it.
It's going to be plus or minus 1.
On top, yeah.
It's going to be negative. So it's going to be 3 and -2 on the bottom.
Yes. Well, because A is 1. Look at it.
Something slight, huh?
Is this the one that's like 2x, x squared minus
He's calling me special.
That's exactly what I'm saying, actually.
I can do that. It's just
Difference of squares is the first term's perfect, which means x squared, and the second term's perfect, and the sign in the middle is negative. It has to be negative.
There you go.
plus 1x squared.
it was, say, x squared minus 9. That would be x plus 3, x minus 3.
What's the other one? What's the other secret?
What? The one I was getting mad about?
Yeah,
What secret are you talking about?
I'm so good.
I don't know, you should probably. I don't like the word.
You Braxton!
We're sharing.
Braxton!
It's plus 3 minus 2.
Minus 2.
Minus
Listen, buddy. Listen here, buddy, bro.
Did y'all get that? If you're still struggling with factoring, please ask me for help in class today, okay? Honestly, the only way you get better at factoring is practice. Just like a sport. Alright, are there any holes? No, no holes. Let's abbreviate what we're finding. What's the vertical asymptote? Very good. So you set the bottom equal to 0. You pull the zeros out. Right? Pull the zeros out. And because this is a vertical asymptote, those are where we're going to drop our highlighted lines. Now, if I said what's the domain, then it would be all real numbers, but you need to skip over -3 and 2. Right? This didn't ask for the domain. But you can practice writing that if you want. Does it have a horizontal asymptote? Yes. Where?
You know this one.
It has a horizontal asymptote at y equals 1. If you don't remember how to get that, it's a leading term test. You check the degrees. It's one of 3 scenarios. In this case, the degrees are equal, which means the horizontal asymptote is the leading coefficient. 1 over 1 is 1. Which means, let's practice this, which means there is no slant asymptote, right? Because if there's a horizontal, there's no slant. If there is no horizontal, then there is a slant. Okay? Let's see. All right, x-intercepts. Right? Change the function notation to 0. Do I even need to write denominator? You can if you want. I'll write it so you know where it comes from. But what's going to happen to all of this when I cross multiply it?
It goes away.
It's gone. So really you're focusing your attention on the numerator. We already wrote that numerator in what format? X plus 1, x minus 1. So what are the zeros?
1 and -1.
Might want to plot those as soon as you answer it, so you don't forget that was a point, not a line. Right? That's not a vertical asymptote. Those are actual points. So you got -1, +1. Okay, y'all got a lunch. Okay, before lunch, we were starting to graph this. We found the vertical asymptotes, which I have not plotted yet, so I'll go ahead and plot those. We've got one at -3 and 2. We found the horizontal asymptote at y equals 1. You can see we have 3 sections. This is upstairs. We have 3 sections of this graph. When I say that, I'm talking vertical section. Like, you got one to the left, you got one in the middle, and then you got one to the right. Clearly, we can see where the graph is in the middle. It's going to be in this section right here. We need to know where the rest of it is. We also need to know where the y-intercept is. Before lunch, we were finding the x-intercept. Replace f of x with 0, cross multiply, the denominator is going to disappear. The numerator in factor form looks like that. Those are the x-intercepts. As coordinate points, it would look like this. Now we have to find the y-intercept. The y-intercept is when x is 0. Go to the function, put 0 in for x. What do you notice is left? -1, -6. So the y-intercept is -1 over -6, which is 1 over 6. Which is hard to graph. So you would go to your calculator and say, what is 1 divided by 6? To get an idea of the decimal, what is it? 0.16. Is that what you said? So it's just a little bit above 0, right? It's not all the way to 1. It's 1/6 of the way. So it's about right there. We're just estimating because we can't actually plot 1/6. Right? Right? You can see the curve is in here.
Amount of water.
Now, where do the rest of this was the new part. Where do I get the rest of the graph from? Plugging stuff in. Let's think smarter, not harder. Plug in where there is nothing, like vertically, right? So there is nothing here, and there is nothing here.
So we do like
So let's pick a few.
-4 and 5 and
Yep.
4 and 5.
Yep. That's fine. And you could go to your table even. You could go to the table if you just wanted to go ahead and get all 4 of those at once. So you can type, we're going to label this as other points. Now I don't have room to write my normal T-chart, so I'm going to write it out as a, what's the word? A horizontal T-chart. Table, but horizontally. All right, so we're going to pick -4, -5. I'm actually going to pick 3 and 4 on the right. So I picked 2 numbers from the section that's blank and 2 numbers from the section that's also blank on the other side. Hello. Okay,
Window.
when you plugged in -3, what'd you get? No. -4, what'd you get? 2.5. When you plugged in -5, what'd you get?
Didn't work.
I picked 3 or 4. You picked 4 and 5. Doesn't matter. We just need to know where the curve is, right? When you plugged 3 in, what'd you get? When you plugged 4 in, what'd you get? 1.25?
Wait,
Is
what?
that what someone said?
I got 1.07. 1.07.
1.07? So I'll say 1.1-ish. If you plugged 5 in, what'd you get? You got 1. Okay. Let's plot these. -4, 2.5. So left 4 up 2, halfway. Left 5, up 1, close to 2. Remember, it's a curve, right? So we have a curve right there. 3 is 1.3, so maybe about right there. 4 is 1.1, and 5 lands where? On an asymptote. Okay. Okay. Why is it okay to hit a horizontal asymptote, but not a vertical?
Because you can't have multiple x values.
Cannot have multiple x values, right? It has to pass the function test. And what is it about the vertical? Like, what is our step in finding the vertical? To find the vertical, we did what? We set the denominator equals 0 to find out what's off limits, right? What is one of the cardinal rules in math? 0. You cannot have a 0 on the bottom. It doesn't matter what the scenario is. So you need to know that while the asymptotes are giving you guidance of where the curves are diverging, a vertical asymptote will never get crossed, but a horizontal asymptote, it can actually touch it eventually. It's okay. It does not violate the cardinal rule. It's just a matter of the leading terms. Remember, that's how we determine that. So that's one of those things where, you think to yourself, is that okay? Yes, it is okay. It just means that this curve is getting right there on it. It's also very rare that you're going to actually pick a point and plug it in and it does land on the horizontal asymptote. Usually that happens further away from where the curve is doing its curve. That's usually where it's leveling out. This would just happen to happen right there. All right, one more practice problem. Let's go do it. Or two. How many are there? Two. Do the next one. While you do that, I'm going to go ahead and pull up that homework. Point. So let's look through it. Okay.
That makes sense.
Let's organize our thoughts. If you will keep it like the same steps, same organization, it kind of helps you remember what to check for, how to check it. So you're setting the denominator equal to 0 and solving. You get a vertical asymptote at -1. Stay with me. Just a little reminder, the HA is a check of your lead terms. You're checking the degrees. In this case, the numerator is greater than the denominator, which means there is none. No horizontal asymptote. Instead, there's a slant, or as it's sometimes called, oblique. How do you find it? Either long division or synthetic division. If you do synthetic division, double check to make sure it's possible. It means that the denominator has to be a 1x. It is possible here. I'm going to do long division. You should notice when you go to fill it in, you should be like, well, wait a minute. There's definitely something wrong. There are two gaps here. There's a gap on the 0x and the 0 at the end. Remember the gaps? If you got stuck, it's probably because of the gap. Because you would have had nowhere to go after that first step.
Yeah. Would you buy a $930 towel skirt?
Let's just come up with a corny way to remember. Like, don't mind the gap. It's like, if you're crossing the street, what's the towel skirt? That didn't work.
A towel skirt. That's exactly what you think it is.
There's a gap. No gaps in your brain cells. Let's check for gaps. Maybe.
That does not work.
No? Okay. I'm trying here, y'all. Throw me a bone.
Hey, I had a big gap in my brain cells yesterday. Hey, I felt fine after that.
Fill the gap with sugar.
Where?
Hey, sugar.
Hey, give me more sugar.
Probably, he's going on tour with,
J. Cole.
Ask yourself,
great.
x times what would be x squared? Then multiply that through. You get x squared plus x.
I do a lot of things.
Draw the line. Change the sign. 0 minus 1. when it is weird like that, you're fine. It's weird like that. Read it out loud, and your mind will probably be like, oh, this is just 0 minus 1, which is negative 1. So negative x, this is not even relevant, but I'm going to pull it down since that's the technique. And then x times what gives me negative x? Negative 1. And if you recall from yesterday, we don't have to find the root. Like once you, and how do you know you're done? So right here, 0 minus 1 would be negative 1. So x times negative 1 would give me negative x. And then you know you're done because if you recall, the slant asymptote is always a line. Lines are always of the form mx plus b, right? Well, there's your mx, and then there's b, so there's nothing else to find. So what is the equation of the slant asymptote? It is y equals x minus 1. Don't forget to write y equals. On my math lab, I believe you have to type your y equals. You do? If you type just x minus 1, it's going to mark it wrong. Now, on the test, I would be able to see that you put it on your paper, so then I can honor it.
Did we get full credit without putting?
Not on the test. I would have to go in and honor it with partial credit. It would be, I would take like 0.9 out of 1. But try to remember it. Yep, I'll be there. I was gonna say, well, let's take the test on Saturday. It's like an ACT session, and I'm like, what?
Are y'all losing about 30 or 40?
We're talking about your grade on Friday? Yeah.
Hey, what about Wednesday, March
Let's
26th?
find the x-intercepts.
Birmingham, Alabama.
I laughed. He laughed.
There's too many cousins.
X-intercepts. Change f of x to 0. So 0 equals, I'm only writing it to remind people that the denominator disappears. I don't want to just write 0 equals x squared because then someone would say, well, where did that come from? So you cross multiply that over and it goes away. So 0 does equal x squared. Square root of 0 is 0, right? Granted, it is a, this is extra, this is bougie. It is a repeated 0 because it's a single answer that came from x squared. You wouldn't have to be able to state that. You wouldn't have to be able to tell me, well, what does that mean? This is just trying to tie together what we've talked about before. Now with y-intercept, remember that replace x with 0. So y is 0 over 0 plus 1. What's 0 divided by 1?
0.
So it's crossing right there at 0, 0. Which was also the x-intercept we found. So there's not a lot to be able to see here. Now we don't have our slant asymptote graphed, so let me graph that. -1, rise 1, run 1. So -1, rise, run, rise, run. There we go, I can see it. So there's my slant.
So can I like infer that one goes this way? And
One of them
goes
is
this way?
definitely right here, and this is what it actually looks like. It is hitting that and bouncing, which is that repeated aspect. Now, how would you actually know that? You would just pick a few, if you wanted to pick another number, plug it in, you could plug 2 in to find out that it's here. How do I get over here?
Other numbers.
What do you want to plug? -4. Okay. And maybe -2. Just for
Y
craps and
equals
giggles.
plus B. MX. is the
All right.
slope, right?
Craps and giggles. You never heard that? I want to hear the real thing. Ah!
That's my sister.
You always say
You
what
start where the thing is. and then you
Oh,
go
right.
down.
Not Let's say it.
Nobody. Nobody.
Here. So you can say the S word, but you can't talk.
Yeah, exactly.
Yeah.
Here's how to stop the acting. Shoot.
Right there. I just want to know
I was
what you
close.
say. The majority. I just hear the tail end of it every time. And I'm like, I know.
I'm big.
What? All right. When you plug -2 in, can you tell me what you get? Yes. When you plug -4 in, can you tell me what you get? Is it -8? -4 would be 16. You get -16 divided by -3. And I don't, so
16 over 3.
16 over negative. I don't know what that is as a decimal. It's -5.3. All right. Left 4, down 5 1/3. Left 2, down 4. There's the curve. Demi, it's barely in there. There you go.
What was -4?
You gotta embrace it.
I'm more of a vertical type of guy.
All right, I'm gonna let that go.
Not drawn to scale.
Letting that go. All right. Last problem. I would say, I think y'all get it. Let's move on. But there's something on the last problem that you've not practiced in a while, and it's a.
I swear. It's -6 and 5.
I'll get away. I haven't looked yet.
I'm just kidding.
It's -6 and 5.
Same thing. It's just instead of just an asymptote, it's going to now
Top
have
part.
a.
It's -6 and 5. The top is -6 and 5.
Who is he?
Where's the white?
So we were all sitting there talking, watching the girls' game. And then Katie hits a three. So I give a little clap because, I thought I hit
Negative
all that,
30.
whatever.
Adds to -1.
Oh,
And Brevin goes,
okay. Let's walk through it. All right.
No, I honestly
Okay. So let's look at this one. What do you notice is uncomfortable about this one? Besides the math. There's a -2. There is a -2 in the front of that quadratic, and that is not helpful here. We're used to the leading term being positive, also a 1, right? But we can fix that negative if it bothers you like this. You could rewrite that as a negative and then parentheses, and then just pull the negative out as a GCF. Notice all I did was pull that negative to the front. You don't want to throw it away. It's still part of the function. It's just now we're tweaking the numerator so that we do have that positive lead coefficient. Okay, now A times C would be -30 that adds up to +1.
Could you please send down Chloe Loman to the front office for dismissal?
Yes, ma'am.
Thank you.
get out.
This was going to be -5.
Make sure to get, I think it's right underneath, nope. That. Take one of these.
I have it.
There you
I got it.
Thank you.
All right.
She meant the pink paper, honey.
Not that one. That's
Factors of -30 that add up to 1.
Oh.
-5 and 6.
Which is fine. Which is fine. It won't matter.
so funny.
Okay.
For you.
Is a 1 You don't have to. I can do it both ways. Do you want me to show you both ways?
Please.
Okay. Would y'all rather not pull the negative out?
Yes.
Still recording.
I already said it.
5 times. Ready? Like, oh my god.
Jack, do you want to move?
No.
Okay. Okay, so if you did not pull the negative out, then you would have negative 30 that adds up to negative 1. That would be,
Negative 6 and 5.
okay. And then remember we talked about when A is not 1, there's an extra step before you can just run with the parentheses. So I'm going to go ahead and write the parentheses, and it would be AX, and then it's the numbers you came up with. So minus 6 plus 5. One set will be done. This one's done. One set will simplify, and when we say simplify, meaning it will reduce by a common factor, and that factor does just disappear because it has to do with factoring by grouping. That common factor in here has already been accounted for right here in the one that's done. Okay, so that's why it disappears. So negative 2x minus 6 becomes x plus 3. Did you get that? No, please don't lock it because I don't know that I have the key. No. Leave in my house. Alright. So we have x plus 3, negative 2x plus 5. So the fraction would now be x plus 3 over negative 2x plus 5. Does anyone want me to continue if you did pull the negative out? Okay. Not a problem. I mean, you still get the same answer. It just, at the end, you would put the negative back in there. So we can run with this. All right, so that's the numerator. What about the denominator? X minus 4x plus 3. A is 1 on the denominator, so you can visualize what are the factors of negative 12 to add up to negative 1, and we get x minus 4, x plus 3.
One of these things is like the other.
And that means there's what in the graph? There's a hole in the graph. All right, I'm going to fix this to match the work we just did, since I'm now on this screen. We said, what did we say, x plus 3 and negative 2x. What was it?
Plus 1.
Plus 5. And then on the bottom, all right, it's in factored form. We are addressing the vertical asymptotes. When you get it in factored form, as Jack said, what do you notice? There is a hole, which means do not drop a horizontal. Don't drop a vertical highlighter on the graph at that hole. It's actually just an open circle. To figure out where the hole is, pull the 0 from it. What's the 0? To figure out what the y value is, plug that negative 3 into the equation that is left over when the hole has been eliminated. I'm going to simplify by writing what is left over. It's usually not a pretty number anyway. So if you plug negative 3 into what's left, you're going to get 11 over negative 7. Now, to help us graph it, we need it as a decimal. So, yeah. Let's see, it goes one time with 4 sevenths left over. That's, yeah, we'll say negative 1.4. Ish. Ish, yeah. There we go. No. No. If you don't like doing that, then just type in the calculator 11 divided by negative 7. You get negative 1 point something. It's going to round to probably negative 1.4. Is it what? So that's where there is a hole. I'm going to go ahead and go to the graph and find it. I got left 3, down 1-ish. There's a hole there. And then now I'm going to finish the problem like normal. Looking at what's left, there's a vertical asymptote at x equals positive 4. Now, horizontal asymptote. This is the terms test. What is it? The degrees are equal, so it's the coefficients. So we've got that the degrees equal, which means it's y equals the coefficients. Negative 2 over 1, which is just negative 2. Which means there is no slant. So keep that in mind. That means there is no slant. To find the x-intercept, go to what's left, plug what in where? To find x-intercept, plug 0 in for y. They switch, they're bass backwards. If I'm looking for the x-intercept, then y is 0. If I'm looking for the y-intercept, then x is 0. It would be helpful to go to the one left over. Don't go back to the original. So once again, I'm showing my work. So this would cross multiply and go away. Solve it. Subtract 5. Divide by negative 2. And I don't have a lot of room to show it, but it'd be negative 5 over negative 2, which means positive 2.5.
So you do the one after the
Yes,
We do the
always.
leftover.
Yeah, once you get it in factor form, especially if there is a hole, always now focus your attention on that cleaned up function. Don't go back to the original. So there's an x-intercept at 2.5. I don't have my horizontal plotted. Y equals negative 2. Now I can see where one curve is, right? I remember these are all curves. They all like go to the vertical asymptotes and then they diverge. This curve with a hole is right there. What section do I need to check to the right of the vertical asymptote? What numbers could I plug in? 6, or even 5. I could plug 5 and 6 in. I need to know where it is over here. So go to the go to the cleaned up one and plug it in. you get? Did you get -5? Then plug 6 in, and then graph it. And you can see that, okay, so that's down there. Okay, I already have 4-4 pulled up. I wanted to look at, I believe it was 8 and 9. I have also moved all of the homework deadlines to Friday night, which means that if there's a couple of homework problems you still don't have done, yes, you can work on it after school Friday and get 100. What about the test?